Hello everyone, I'm Brent Mitchell with Red Castle Resources. We're a small geospatial firm, and today I want to talk to you about ASKTERRA, a revolutionary GeoAI platform that allows everyone to interact with Earth observation data through natural conversation. Instead of spending hours writing code or hunting for data, you can just ask questions in the way you naturally think about them. And within seconds, ASKTERRA will give you results that you can explore, iterate on, and share with other users. This is the case whether you are mapping deforestation around the globe, looking at agricultural change over time, or forecasting weather and the associated risks. For GIS professionals, this means accelerated workflows that you can refine inside of ASKTERRA or export into your other GIS software. For newcomers, ASKTERRA opens up Earth observation data through conversational queries. No learning advanced software, just ask the natural question and explore the conversational response and the map outputs. So now let's jump into ASKTERRA and explore the interface and go through some of the features and capabilities of ASKTERRA. So when we start looking at the interface here, we'll notice a couple of main features. On the left, we have the conversational panel. And you can see that because you haven't used it yet, we've given you a bunch of examples of different types of conversations you could start with ASKTERRA. And as you'll notice, there's map forecasted tree damage risk. We can map things into the future. Map forecast over the next 10 days over the entire US. Another forecast. But then we can also look at to-date change detection, urban expansion, water level change, wildfire, snow cover change. So lots of different types of change on the landscape that we can map. So maybe let's go with this. Let's start this conversation about snow cover in the Eastern Sierra and how it's changed between 2024 and 2023. So we can just click that conversation and it loads it down here into the prompt. Now we could have typed that, but since we're getting started, we're not sure what kind of questions we want to ask. So we're going to lean on ASKTERRA for some example questions. So this brings us down here to the prompt window. This is where you interact with ASKTERRA and start the conversations. And so as we get going, you'll see as I type different things in, we kind of converse back and forth with ASKTERRA and get it to give us the results that we want. And then staring us right here in the face in the middle is the map interface. Now this is where once you run the prompt, your outputs, your map outputs will be displayed here. So let's go ahead and run this prompt and explore what everything kind of looks like once we get some results and some data. Just while it's processing, let's look at what we asked it, just to kind of think about that for just a moment. We said map differences in snow cover. So we asked it for a change, we gave it a vague location, and then we gave it some dates. So to-date change detection to look at snow differences in the Eastern Sierra Nevada. And we know that it is a change detection platform, so that's what it's going to react to. So now we see here that it's centered itself on Bishop in the Eastern Sierra. And I'm kind of thinking we're a little bit away from the mountains. So let me just pull the map over here. Okay, there we go. There are the mountains. So because we gave it a vague locational request, it went to the Eastern Sierra and centered itself on a town that it recognizes there. So let's explore both of our answers. So we have the map output and we have the conversational output. So first let's just look at the conversational output. The nice thing about this is that ASKTERRA gives you a summary and a description of the map products that you just got in the map output format. So it tells us that it selected a region, it gave us a Latin long for that region, it told us the dates that it wanted to use. It also tells us the normalized difference snow index is the indice that it chose to highlight the differences in snow cover. You'll see that it kind of deciphers the map for you. This map will highlight areas where snow cover has decreased in red or they have increased in time by blue. So remember, we're comparing 2023 to 2024. So if there's more snow in 2023 and less in 2024, it'll appear red. And if there's more snow in 2024 than in 2023, it'll appear blue. It's also given you some citations about the snowpack in the Eastern Sierra and those seasons of snowpack. So you get a lot of nice information to learn about the area you're inquiring about. So in the map output here, we're looking at a change detection. All those red pixels, right? And let's look at the layers that are being displayed. So we can turn this change detection on and off, right? Flicker and on and off. Underneath, you'll notice there's a base map. This isn't the imagery used in the analysis. This is just a base map for your navigation. If you go up here you can see that we have all sorts of different Esri base maps that you can use. Maybe you want to use a topographic base map. You can just switch it up, turn on the change again, and drape that over. I like the imagery hybrid. It gives me some context, but also gives me the imagery in the background. So not only do we have the change output, but we have the raw data used to create this change. So what's nice about ASKTERRA is you don't just get the answer, you get the data that was used in the algorithm to create the answer. And this allows you to qualitatively inspect the logic used to give you your answer. So you can see we have a composite from May of 2024 and a composite from May of 2023. These are both Sentinel cloud-free composites for those dates. And as we flick those on off, right now we're looking at 2024. As we turn that off, we see 2023 underneath. And you can see quite a difference in the extent of snow cover, much more in 2023 than in 2024. And then when we look at the change, that is reflected in that output. So you asked ASKTERRA a question, you got a conversational response that sort of gives you the logic of your output and gives you some context of why it did what it did. And then you have this map output that you can leverage. So now that we've explored the snowpack and the Eastern Sierra, maybe we want to explore something different. So a nice feature in ASKTERRA is that you can start a new chat. So you can keep your different analysis separate. And you come back to them later. So if we come up here to the little chat icon, we can click here, we can say new chat. So now we're starting a fully new chat. And so now let's go down here. We don't want to map that anymore. We want to do something new. And since I live in Utah, I'm interested in the impacts of wildfire this summer. And I know there were some wildfires on the Fish Lake National Forest. So I know they were this summer. I know generally where they were, but I don't know exactly where they were. And I don't know the exact dates. But let's see if ASKTERRA can help me map them, and then we can explore those. So we can start a new prompt, and we can just start from scratch down here in the prompt window. So map landscape change from wildfire in Fish Lake National Forest in Utah, summer 2025. So map landscape change from wildfire. So we've got a change we're looking at. We've got a location, Fish Lake National Forest in Utah, and we've got a time frame, summer of 2025. So, and we've got this in our new chat, right? So let's go ahead and run that and see what ends up happening. Okay, just like last time, we're getting our conversational answer and we're getting our map answer. So again, we're getting some context for our map. So let's first go here to make sure we understand what we're viewing in the map. So the region selection, it identified the Fish Lake National Forest in south central Utah, and it actually identified the fire that was burning during the summer of 2025, the Monroe Canyon Fire burn scar. So it's telling us what burn scar it's mapping. Down here, we talk about the different pre-fire composite that it used and the post-fire composite that it used. And it chose the same time during the year before. So by doing that, we minimize any seasonal leaf-off, leaf-on effects. We look at the same time of year at different times, different years, and then we can just map the change we're looking at, which is the fire change, not any other kind of seasonal change. It also tells us that it used the NBR, normalized burn ratio. So maybe we're thinking, well, what is the NBR? So we can actually have a conversation with ASKTERRA and say, what is NBR? And see if we can get a little bit more explanation around what that index is and why is it used to map fires. So we're not changing the map output. We're just having a conversation with ASKTERRA about the choices that it's making and the maps that it's creating for us. So here it tells us that the normalized burn ratio is a remote sensing index specifically designed to identify burned areas and measure fire severity using satellite imagery. And then it gives you kind of the band math, what bands are used in the index, et cetera, et cetera. So you can learn more about remote sensing and change detection when you're using ASKTERRA. So now if we go back up to the original explanation, we still have access to that. Gives us more context. It also talks about the threshold used in that index. And it's highlighting the vegetation change, right? So When we zoom into this change and start to explore it, so again, let's turn those layers on like we did before. We've got the change layer. We can flick that on and off. Let's turn on the raw data used for the analysis, our 2025 and 2024 composites. So if we look at that, we can see in 2025, there's a burn scar. In 2024, it's green and healthy. And so when we look at that and we look at the change, we might think, well, maybe it's not representing all of the damage from the fire. Maybe we want the index to be a little bit more sensitive. So the idea here is that you're not stuck with what ASKTERRA picks when you do the when it does the initial analysis. You can continue to refine your analysis. So in this case, I can ask ASKTERRA, can you rerun this with a more sensitive index, index threshold. And let's see what it does. And it did exactly that. So it's running a more sensitive threshold to map the fire. And you might notice we've got a little bit more change detected because we changed the threshold. So this just exemplifies that you're not stuck with ASKTERRA is smart in its initial analysis, but you might want to cater it and refine it yourself. So you can continue the conversation and refine your map product. So now we zoom in, we can see that maybe it's detecting a little bit more change. Maybe we like that, maybe we don't. But we can see that all those areas of change are being mapped now, and maybe we're a little bit more satisfied that all the vegetation affected by the fire is being mapped. Now, one other thing I want to draw your attention to is you see a lot of red and blue on this map. So the thing to remember about ASKTERRA is it's taking that location and it's running the NBR index and it's mapping all the change on the landscape, not only just the fire. So it's taking those tiles, doing the differencing and mapping all change. So we actually see some areas of actually regrowth or blue on the map. So that's saying that vegetation got healthier between 2024 and 2025. So this is an interesting example over here. So if we turn off the change and we look at the 2025 imagery, and then we look at the 2024 imagery, you can see there was probably a fire in 2024 because we can see there's not much green left. It's a very distinct fire scar. Now if we zoom in, we can see it subtly when we turn 2025 on. There's been a little bit of regrowth since the last fire, and then this change detection is picking that up. So not only can you map the burn scars and the removal of vegetation, but you can also map regrowth with these indexes. So just a point I wanted to highlight to you all. Now, there's also a lot of other tools available to you when you're working with ASKTERRA. We go over here, we have the base maps. We talked about those earlier. This can take you to your current location, which I won't do because it'll fly us away from here. We've got some GIS tools. We've got distance measurement. We've got area measurement. We can stop that. We've got a nice feature, which is you can create a PDF report from this output. So let's say I want to zoom in on this fire. I've got some land managers. They're very interested in the extent of this fire scar, what areas it affected, how's it going to affect their management in the future. They might not be GIS folks. So with this feature here, we can just create a PDF report that will give them the pre and post imagery and the change detection output and a little bit of a histogram highlighting how many pixels in the proportional area you're viewing changed. So, and a little bit of an explanation of the analysis that you've just run. So, nice way to communicate things on the landscape to people who aren't savvy in GIS and just need a quick report. Some other tools here is you can download just PNG images. You can download GeoTIFFs. So as a GIS expert, you might think, well, this is great, but I want to do all this other stuff with the data. No problem. You want to just create cloud-free composites and then export those into your GIS and do your own analysis? You can do that with ASKTERRA, no problem. Download the GeoTIFFs and off you go. We can also create tile services of all these layers, so another option. Last thing I want to talk about with features and tools is this collaboration tool. You can share this conversation and this map with other ASKTERRA users. So you can just copy this link, and then I'm going to send it to myself here, but you could email this to someone potentially. And if they're an ASKTERRA user, they get that link, they open up their instance of ASKTERRA, and it loads your conversation and your map outputs live. So they can kind of go through what you've done. You change the indice, they'll be able to see that. They'll be focused on here on this burn scar, and then they might continue the conversation. So they can collaborate with you from all the things you learned and as far as you got, and then take that to the next level if they want to. Or they at least understand exactly how you got here. So a really nice collaboration feature. Okay, so a lot of you might work in areas where they're remote. They might be kind of hard for you to prompt ASKTERRA to get you to the exact location that you want, and we realize that. So we created another feature here that allows you to just navigate an area inside the map view. So when I click that and I start to scroll around in my base map, you'll see instantly that the lat and long pop up for the map extent. So let's say that I'm interested in a particular area of almond groves that I've been tasked with managing. And I'm looking at this farm, I'm responsible for its almond production, and I'm concerned that the almond groves from this season aren't as productive as last, and I need to be prepared if they're not. So I've zoomed in here just south of Bakersfield, and let's say on these plots of almond, or these groves of almonds that I'm in charge of handling and making sure that they're healthy. So now you can see, instead of me trying to prompt and get exactly where I wanted to go, I just navigated there in the GIS. And now I can prompt on that location, map almond grove health between 2024 to 2025. So we're using this region, we're mapping almond grove health between 2024 and 2025. And the nice thing about ASKTERRA is it takes care of your typos and interprets those, so you don't have to make everything perfect. It's not like a script. It can actually deal with that, which is nice, because we all have fat fingers, or most of us. So here we go. We're on the same area, and we've got your region. It's giving you a map of the almond groves in California's San Joaquin Valley, precisely within the coordinates you provided. So you could do this in a forested landscape, in a BLM rangeland landscape, anywhere you want. Anywhere on the globe is good to mention too. It's used a preseason composite, March, April 2024, a postseason composite in 2025. So you're kind of looking at the leaf out initial canopy development. So maybe I'm thinking, well, why did it use March and April of 2024 and then July mid? So I wanted to use the same date. So I'm just going to say, can you use July and August for both pre and post imagery? Because I want to compare apples to apples. I don't want to see the groves when they're just leaving out and then when they're mature the year after. So I want to rerun that analysis. So again, you can see, you can have this conversation and you can refine what you're doing. And so it's done that for us. It's used July and August of both years. That's what I would prefer. Again, right, we see the blue and red pixels. It's using an NDVI index. So as you might recall from the demo, when we looked at snow and ice, it used the NDSI. When we looked at fires, it used the NBR. Now we're using the NDVI. So ASKTERRA is smart enough to know, based on the type of change you're looking at, which index optimizes for that change. So just something to note. It also gives us, again, right, our threshold. We could change that if we wanted to. Red areas decline in almond grove health. Blue areas an increase. And it gives you some more context. And again, some nice links that you can explore, some logic and some information about these areas and research on online. And let's check out the layers again. We can see the red and the blue representing the decrease or increase in greenness between the 2 years. And then let's look at the layers, the data behind this analysis. You can see in 2025 what's green and what's tilled and not green. And then in 2024, we can see those differences. So pretty stark differences here on what's having healthy almond groves, what's not. Now, we see these very obvious ones that were there and then not there. But then we also see some other change I think is quite interesting. So this center square here is green. It shows a little bit of red. If we look at the base data, we can see that in 2024, it looks very, very green. 2025, maybe a little more stressed. So that's kind of giving us an indication of maybe some decline in health. So not a full change, but maybe more of a subtle change. So again, maybe this is a case where you might want to tweak the thresholds and hone in a little bit more. So again, some nice scenarios there. So we focused a lot on to-date change detection, exploring snow cover, exploring vegetation change from fire, exploring agriculture change and health. The other function of ASKTERRA is forecasting into the future. So we have the Google DeepMind's WeatherNext models that forecast climate variables or weather out 10 days into the future. And alongside that, with that predictive power, we've built a tree blowdown model. So we're taking the max wind speed that WeatherNext can predict and combining it with tree type and tree height and making a prediction about how much wind will snap a tree and create blowdown problems. So this, as you could imagine, could be helpful for utilities, managing streets, managing forest damage. So let me do an example of that for you. Now we don't have a hurricane this season with high winds that have created tree blowdown, but we can go back to Hurricane Helene because it created quite a bit of damage from tree blowdown. So let's do that. So let's say predict tree blowdown from Hurricane Helene in 2024 in Florida. So we asking it to predict something. So predict tree blow, not show me change, but predict tree blowdown from Hurricane Helene in 2024 in Florida. So let's give it that. Now we are looking back in time, so it's a little counterintuitive, but the idea with what we're going to see is that you can predict this 10 days into the future. So if a hurricane or some sort of climatic event is approaching your area, you can look into the future 10 days and maybe try to mitigate risk. That's the idea here. So now we're seeing this map load, and we're going to explore these layers. Again, right, we get a very nice conversational output from ASKTERRA and the map product. So this forecast covers the Florida Big Bend region centered near Perry, Florida. It talks about Hurricane Helene, Category 4, when it made landfall. The date selections that we're using, we're starting on the 26th, ending on the 28th. So we're doing some predictions here. It talks about the forecast and explains what it is. So you get an explanation of the output map products. We have the tree damage risk layer, highlights areas where wind speeds and soil saturation combine to create the highest likelihood of tree uprooting and blowdown. And again, lots of context, and again, we get some citations to support our map product. So let's zoom out a little bit and explore this map. You can see the path of Hurricane Helene right into Florida, Georgia, South Carolina. So this is our max wind speed. So let's explore our layers. That's this one being displayed. We also have this Gales model. This is the blowdown, predicted tree blowdown model. And you can see that in the purple along the path of the hurricane here. Lots of tree blowdown where it makes landfall up through the west side of Georgia, South Carolina, near Asheville. A lot of you might recall that Asheville had severe damage from Hurricane Helene, not only from tree blowdown, but also from flooding. And when we look at the total precipitation from that time period, you can see that around Asheville was heavily affected, and that lines up with what we see on the landscape, a lot of flood damage. So the idea here is that we're predicting into the future using WeatherNext from Google, and right now we have the tree blowdown model, but coming soon will be fire risk models and flood models based on the weather predictions and the geographic and GIS data around that. So you'll be able to predict and prepare for future events. So we've gone through the functionality of ASKTERRA, to-date change detection, and forecasting climate variables into the future with associated risk models. Now, there's some caveats with ASKTERRA. It's mapping change. So when we asked it about the Fish Lake National Forest fires in 2025, it found the Monroe Canyon fire, and it centered itself on that and mapped that change. So in that scenario, we're pretty confident that the change we're seeing is from that actual fire. But there was a lot of other change in that image also that wasn't necessarily We don't know what that change is from. We know that it's a change from 24 to 25, but we don't know what caused that change. When we examined that other fire scar and saw there was regrowth. So we can make an assumption that a fire burned sometime in 2024, and now it's regrowing back in 2025, but we don't know that. We also saw some agricultural change on the landscape. We're not sure what that's about. Why did that happen? Was it not irrigated? Did it not get planted? So the idea is that the change is mapped, and it will give you some context in the conversational pane to help you decipher what that change is from. But it's not classifying the change. So just some caveats to think about when you use ASKTERRA. This is a very good starting point to get you started in seeing what's changing on the landscape. And from there, it's up to you to have that conversation with ASKTERRA and use the information that it gives you to be more informed about our world and its changing landscape. One last thing I'll mention is we've made ASKTERRA very user-friendly and transparent, and you are allowed to track your own usage in real time, so you can see how many credits you're burning on your total per session, how many of those are going towards Earth Engine streaming, and how many of those are going to your LLM costs. So you're able to monitor the costs you're incurring while using ASKTERRA. So that's all we got. Thanks very much, and we'll see you soon.